Hi everyone, welcome to Trigonometry. Today we explore lesson 18, vector projection and applications. Number 1, vector projection. Let's say we have a vector A, this one, and we want to project it onto a vector B. Well, in order to do the vector projection, we got to project it onto B so that it makes a right triangle. This component of vector A, the x component, is called component of A onto B. And the notation is com A onto B, which is the magnitude of A multiplied to cosine. Well, this is the angle theta. Cosine of the angle theta. And because we know cosine is A dot B over the magnitude of A times magnitude of B, this becomes magnitude of A times A dot B over magnitude of A times the magnitude of B. So which is A dot B over magnitude of B. See, dot product is a number. Magnitude of B is the number. So this is a real number. Now, a component of A onto B is also called the scalar projection of the vector A onto B. Some people use scalar projection. Next is, well, we got to figure out the vector projection of A onto B. Vector projection of A onto B is we turn the component A onto B into a vector, and to do that, we got to multiply the component of A onto B by a unit vector along the vector B. A dot B over magnitude of B multiplied to unit vector along B is B divided by its magnitude. And this gives us A dot B over magnitude of B squared times the vector B. Yay, this is a vector. The scalar A dot B over the magnitude of B squared is just a real number. It's a scalar. So as you can see, when we do the vector projection of A onto B, we get a vector. It's some multiple of or some scale of the vector B. Okay, let's take a look at an example on how to do the computation. Example, find the component of A onto B and the projection of A onto B given vector A is 1, 1, 2 and vector B is -2, 3, 1. Okay, let's do it. Component of A onto B is given by the formula A dot B over magnitude of B. So that would be a 1 times negative 2 plus 1 times 3 plus 2 times 1 over root of minus 2 square plus 3 square plus 1 square. And this gives us 3 over root of 14. Next is the vector projection of A onto B. Is the formula A dot B over magnitude of B square multiplied to the vector B. Well, we know A dot B, that is 3. We know the magnitude of B, which is root of 14. We just have to square it, and then we multiply to the vector B. Negative 2, 3, 1, which give us 3 over 14 times negative 2, 3, 1, and we can distribute the scalar inside. So we have a negative 6 over 14, 9 over 14, and 3 over 14. 2. Application in stopping force. Example, find the force needed to keep a 4,000-pound car from sliding down an inclined tri-way up 20-degree angle. First, let's draw the tri-way. So this is the tri-way here. And it has an angle of 20 degrees. Somewhere here's the car. Weight is the vector. So this is the weight of the car. In order to figure out the force needed to keep the car from sliding down, we need to project the weight onto the tri-way. I'm going to project the weight onto the tri-way. And this right here is the force needed to stop the car from rolling. Well, how is the unit for force? So the force right here is the magnitude of the vector F. As you can see from here, magnitude of the vector F is the force needed to stop car from rolling. And that is exactly the scalar projection of W onto the tri-way, which is the magnitude of W multiplied to cosine. Well, we just have to figure out the angle. Carefully look at this right triangle. You see that the angle right here is 90 degree minus 20 degree. So it's cosine of 90 degree minus 20 degree. And so this magnitude of wave multiplied to, well, there's an identity that tells us that cosine of 90 degree minus the angle theta is exactly sine of the angle theta. So sine of 20 degree. And so it is 4,000 multiplied to sine of 20 degree. That is approximately 1,368 pounds. 3. Application in work. Example, a wagon is pulled a distance of 100 meters along a horizontal path by a constant force of 70 Newton. The handle of the wagon is held at an angle 35 degrees above the horizon. Find the work done by the force. Okay, so we have this is the wagon. And it is being pulled at an angle of 35 degrees above the horizon. It's the force factor. Yeah. And it is being pulled by a distance of 100 meters. We can turn the distance into a vector. That is the vector D. Work is defined in physics as force times distance. In physics, work is force times distance. Here, force is a vector and distance is the vector. So we have work is the dot product of force and distance. Using the angle definition of the dot product, we have the magnitude of force multiplied to magnitude of distance, cosine of the angle between the two vectors. And then from here, well, we get a force is 70 Newton, distance is 100 meters, the angle is 35, so cosine of 35 degrees. And this gives us approximately 5734 joule. J stands for joule. Thank you for watching. I hope you find the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.